Hi, I'm Brian Fields, amateur radio call sign W9CR, and today, no, this evening actually, I'm out in my lab. Um, Based on some comments on Facebook, people were defending the new Chinese Baofeng, well, not new, but the last few years. So, anyways, I bought one off of Amazon recently, and this is it right here. It's if you can see it. It's a Baofeng UV-5RA. And I got a little antenna connector on it here, hooked up to the test equipment here. I did some testing this evening, verified some stuff. One of the things I will show here is it's Part 90 certified, so it should confirm at least to some very basic stuff, emission mask, whatnot, which is all I'm testing for right now. And I'm not testing for the emission mask close in, because there's a close in emission mask that goes kind of like this and then over. I'm testing for just the greater than 50 kilohertz away from the carrier frequency emission mask with my test setup here, and I want to show what my test setup is in case there's maybe a problem with it that I'm not capturing. Somebody can correct me on it. I'm not certainly not above failure myself. And this is the Baofeng here, and let me flip around here on the camera and I'll show you. So this is the back of the Baofeng, and it's a UV-5RA, and you see right here it says complies with Part 90 of the FCC rules. Here's the FCC ID. Here's the serial number of the device I have. It's a two-way radio, Baofeng, and put the battery back on here. Okay.
Frequency mode.
And just to be certain, I tested it on UHF and VHF. I haven't really programmed anything, but since it is commercial, I tested it on 150. And I'll show you my general procedure here. This is making some noise. Let me turn that down. So I have connected here, and I'll back away. I have a Sukaflex test cable. It's 1 meter off the radio. There are some adapters involved here, but this is a goes to a APC7, APC7 to female. This is a male-to-male connector into the power meter, and you can see on the power meter here, this is a bird. And it's the selectable one. This is a 144 to 520 megahertz slug, 1 kilowatt, which would mean when we turn it on here, you're going to multiply that number 1 times that factor, so 10. So 10 watts will be full scale on the 1 scale right here. You can see the very top scale is what we'll use. And let me set this down. I'll show you. On VHF here, we're about 5.2 watts. I'm keying down, and it settles right about 5.2. I know it looks like a little bit more, but it's 5.2. And there's, at that frequency, I calculated it out here in my cable loss, per meter is 0.090 dB of loss. Say 0.1 dB because I probably have a little bit of loss in the connectors here. Certainly not in the APC or the end connector here, but in this setup. And then from here I go into a 30 dB power attenuator, and this is I've checked this on my VNA, but I will show you it's a NARDA high power microwave attenuator. I'm going to flip it around here so you can see. It has a derating curve, and it's good up to 6 gigahertz for the most part, with a 30 dB return loss there, or 30 dB insertion loss, I should say, since it's a power attenuator. I've checked it. I haven't had it officially checked and calibrated. None of my equipment has been officially checked and calibrated, aside from what I've done myself. So I'm an amateur lab. I'm not a professional lab. And anyways, coming out of this, I have Sukaflex 2 meters of end male to end male up there, and this is just a stress relief. Sukaflex 104, same cable, PEA. It's the armored version of it. That's why it's a little bit thicker. Again, this is high quality test equipment cable, test cable that I use on my VNA. So I have this here, which is my spectrum analyzer. Let me see if I can get my. Now I have. We have, assuming we're Part 90 narrowband compliant. According to Part 90, we are in mask D, and basically what that is greater than 12.5 kilohertz away. We need to be 50 plus 10 log P dBm. And for VHF, power out was 5.2, which means that our attenuation needs to be 57.16. On UHF, that needs to be 57 dB. It's actually 56.989 dB, 57 dB down. Now, there is a little bit of error between everything here. Correcting for that, there's probably about a half dB error in everything. Certainly under that, but I have 5% full scale accuracy on the meter here. So, that could be plus or minus a half watt there. And my power accuracy here is, where is it? We could be within 4% of power accuracy here. So, it's within a little bit. I looked at it. We're reading 5.91 dBm here as the fundamental at 450. Again, this is saying it's 448 here. It's a process of the resolution bandwidth we're dealing with. So, assuming that we're 5.91 after the 30 dB attenuator, that would make us about 36 dBm, which is well, it'd be 36.4 dBm or so, which is again within about a half dB of the 5 watts output that we've measured on UHF, and VHF agrees almost the same with those numbers. So, anyways, you can see our UHF here, and knowing that we're 5.91, we just subtract 57 dB from that, and I've made a reference line at negative 51.09 there, which is again 57 dB down from 5.91 dB or dBm, plus 5.91. So that's where we're at and what we have to be. And you can see right here, the second and third harmonic don't even come close. The second harmonic is negative 38.63, and that's that's significantly that's what that's nowhere near what it needs to be. It's in excess of 10 dB. The third harmonic at 1.3 gigahertz actually is still negative 43, so it's a little bit, it's 9 dB over where it should be. Now, what I will do is I'll set up and I'll show VHF here. So let me do a measurement on that, and I'll be back with you. Okay, back with you here, and I have set up on the 150 here, and here is the watt meter, and you can see that about 5.2 watts right there, right on the money or so. And I'm going to do the same thing now on the spectrum analyzer here. Okay, back with you here. I have that display line set up, and you can see it. It's actually a little bit better by about 1/10 of a dB, or a few tenths of a dB. So we're negative 53.35 dBm, which is 57 dBm down from 6.65 dBm, and that is 1, 2, 3, and 4. And as you can see, 2, 3, and 4 there being the first, second, and third harmonic respectively. They do not clear that at all. They are significantly worse by 2 and 3 there by 10 dB. 3 is actually much worse It's worse than the second harmonic. So and that's in the Part 90 spectrum. That's down at 150 megahertz. And again, that's using my setup here of the Sukaflex coming off of this. Focus there. Okay. Here's our Sukaflex cable here. You can see we got about there's 2 meters there. Goes into a 30 dB attenuator. The power meter, and then N-male to N-male coupler, female APC7 to APC7, another meter of Sukaflex cable into a quick disconnect into the radio. So I did use the radio. I made a few contacts on it through a repeater about 20 miles away. It certainly seems sensitive. The S meter is damn near next to useless, but you know, it's what do you expect? But you know, as of right now, this is, you know, this doesn't comply with Part 90. I haven't checked the close in, but certainly on VHF and UHF, it does not comply at all. So, anyways, I would really caution somebody on buying one of these, and anybody that's going to say that they, you know, they're fine, you can use them, whatever. They're not. These are really not legal to use. They spew crap everywhere. And I mean, my spectrum analyzer registers harmonics, you know, out almost all the way to 1.5 gigahertz on UHF, which is pretty bad. Most stuff on UHF, most commercial radios, you can't detect the harmonics on it unless you get a terminated diplexer or something like that, so you can extend the range of your spectrum analyzer. So you know, this is going through a 30 dB pad here. This is a very basic way to measure it. So again, if I have something wrong with my test setup here, or you know, I've done my math wrong in terms of what the FCC requires, you know, please let me know. But you know, if I did something wrong, you know, I'll correct it and stand up and say so. But based on my calculations here, and I've triple checked before I put this stuff on YouTube, these are certainly not Part 90 certifiable radios. So I would be very cautionary. Excuse me. I would caution anyone to use these on even amateur radio, because from an amateur radio perspective, they don't pass on VHF. Again, UHF for amateur radio doesn't have a spectral mask, but you know, you would want it to be, you know, at least 40 dB down, and you know, it's not even that. Generally, is what I would say. So. Anyways, again, this is Brian Fields, amateur radio call sign, W9CR, and appreciate you looking at this Baofeng video.